Okay, guys, you just missed it. Nathan just called me old.
No.
Yes? Noah? Did he just call me old?
No.
Yes.
No.
Yeah. Oh, that was a yes.
No.
It was bad, Georgia.
It was not bad.
Natalie. Justin, maybe. I think Justin's gonna watch it.
No.
Definitely not.
I think he will. I think he'll watch. I think he'll watch it when he gets back.
He might.
I think that Natalie and Georgia will probably watch it before they get back. Or maybe Georgia the morning of. Is it Monday morning that you're back, Georgia, and you're watching it now? Natalie is for sure already watching it. Like, she might be watching it while I record it. Okay, here we go. There are two ways to do hypothesis testing. There's one way called rejection regions, and one way called p-values. They're exactly the same thing. One is using a z-score. This is comparing z-scores. And this one is comparing probabilities. And we're going to learn both kinds. Most scientists like to use p-values. I really like rejection regions. I mean, both make sense to me, but you can't just rely on one or the other because the AP test will ask you on both. Okay. So here we go. We're going to do steps for a rejection region. First step is that you verify that sigma is known. This is for a mean. And it's either random or what? I'm sorry, I meant normal, not random. So it's normal or, do you guys remember the central limit theorem?
Is it 30?
Yes, n has to be greater than or equal to 30. So this top one is required. Sigma has to be known, and then it has to be normal, or n has to be greater than or equal to 30. This is in the problem. Number 2, you're going to, state H sub O and H sub A, which is the null and alternative hypothesis. H sub O, H sub A, remember this is the one with like an equals of some sort in it, and this one is like, so it could be like less than or equal to or greater than or equal to, where this one would be not equals to or greater than or less than. And remember, either one can be the claim. Okay, next, you're going to determine the critical value This is using A16, A17, and drawing a picture. You don't have to draw a picture, but I highly recommend it, at least at the beginning while you're learning. Critical value is the edge of the rejection region. So then you determine the rejection region. The rejection region is in the tail. So do you remember how we had like two-tailed, left-tailed, right-tailed? The rejection region is in whatever that tail is. Okay, next you find the standardized test statistic. Which which is another word for z-score, but I'm writing out this so that you don't get thrown by it. Remember the x minus mu over sigma, only this time it's x bar minus mu over sigma divided by the square root of n. And the first thing you do is accept or reject the null.
Wait, it's sigma divided by the square root of n?
Yep. No, this is the central limit theorem, how it changes. It makes it, remember that if we don't have the outliers, this makes the value a little bit bigger. Accept or reject the null, and then finally accept or reject the claim. And then over here in the reminders, I'm going to put context sentence. So don't forget that you have to explain what just happened. And then I'm going to try an example of this with you. And then you're going to try one with each other. Okay? All right, I'm going to keep going back to the steps so that you'll be able to see it up here. So just go to example 1 now. So example 1. Employees at a construction and mining company claim that the mean salary of the company's mechanical engineers is less than one of its competitors, which is $68,000. So they're saying that basically the people at their company is less than $68,000. Noah, are you writing with a marker?
Hey, you know.
Okay. You chose a light pink marker?
Yeah.
Guys, we're falling apart without you. This is getting horrible at this point. Okay. Verify that sigma is known. Do you see how it says assume that the population standard deviation is 5,500? So you can write that sigma would be 5,500. And that it's normal. So that's step 1. I'm going to write a little 1 by that and write check like we did it. Step 2 is to state the H sub O and the H sub A. This is what you guys practiced yesterday, the null and the alternative. All right, now we're talking about means, so I'm going to write mu for both. What is their claim?
Is less than 68,000.
Right, so where should less than go? Should it be the H sub O or H sub A?
H sub A.
Yes, it's anything without an equals. I'm going to write claim after this one. What's the opposite of that?
Greater than or equal to.
Okay, that was step 2. Step 3, determine the critical value. So I'm going to draw a picture. Draw a quick, beautiful bell curve. Ooh, this one's really good. Look at that sharp angle in the middle of my bell curve. Nice. All right, is it left-tailed, two-tailed, or right-tailed?
Right-tailed.
No. It's always the alternative. The alternative is the tail. And the alternative is less than, so that means it's over here. I'm going to write null over here. So it's always whatever the tail is, which is the alternative. All right, now the critical value is this value right here. And we're going to use A16, A17 to find that. So look at your A16, A17. There's extra copies over there if you need one. Or you could look in a book. Okay, now, do you see how this says alpha equals 0.05?
Yep.
Okay, that's the level of significance. That means that we've got a 5% chance of error. So if I was going to look that up, do you remember how the table reads to the left? So I'm going to look up 0.05 in the middle of the table. So in the middle of the table, you're looking at 0.05. Which is halfway between these two, that